All right, here we have another example of a polynomial inequality, x squared greater than or equal to 16. And once again, we want to find the key points, which would be the zeros. So in order to do that, we can simply think of setting this to 0 like we did before. So we would have x squared minus 16 is greater than or equal to 0. And if we factor this, we could factor this to simply x plus 4 and x minus 4. So then that would give us that x would be equal to negative 4 and x is equal to a positive 4. So this is our key points, or the zeros. This is where the graph will cross or touch the x-axis, and this will give us a possibility of where our signs would change from positive to negative or negative to positive. All right, another way we could have done this problem here to get to the negative 4 and 4 would be to leave it as x squared is greater than or equal to 16. And if you think of this as solving for x, we could simply take the square root of both sides. But remember, when we take the square root, we would have to make that a plus or minus. So x would be equal to plus or minus 4. Okay, so that gives us the same answer we had over here. So if you didn't want to factor this, the easy way would be to take the square root of both sides. Now, once we have these zeros, these key points, that will allow us to set up our test intervals. So if we think of going from left to right on the number line, we start with negative infinity. So if we're going from negative infinity all the way up to here, we have negative 4. And then we're going to start from negative 4 and go to positive 4. And then from positive 4 to positive infinity. So if that's our test intervals, we now need to pick a test value. And that's going to be a number that falls somewhere in each of these intervals. Well, again, I'm going to pick a number to the left of negative 4, so I'm going to pick the smallest number there, which would be a negative 5. We need a number between negative 4 and 4 is 0, and something bigger than 4, I'm simply going to use 5. So now, after we have our test value, we want to know what is the polynomial value, which simply means we're going to take this number now and plug it into the polynomial. So we want to plug that into here, where we have x squared minus 16, and what is that going to equal? Well, once again, if we want to, we can go to the calculator, type in the polynomial, and I'm going to do that as here we have x squared minus 16, zoom 6. So we see the graph, but I want to go into the table, and we're looking for negative 5, 0, and positive 5. So if I enter those into the calculator, negative 5, zero, and a positive 5. So if we do that, we're getting out 9, negative 16, and 9. So we have 9, negative 16, and 9. So from this, the conclusion, and remember the conclusion we're looking for is it positive or negative? Well, here we have a positive, a negative 16, and then a positive 9. So the question now becomes, what is going to be the solution Well, be careful. If we go up here and look now, we have x squared minus 16 is greater than or equal to 0. So if we're looking at values greater than or equal to 0, then that means we're looking for positive values, and that's going to occur from negative infinity to negative 4 and 4 to infinity. Now, keep in mind though, this actually said what? Greater than or equal to. So that means we're actually going to include the endpoints. So we would write this as a negative infinity, and we're going all the way up to negative 4, and because it can be equal to negative 4, we're going to use a bracket, and then we're going to join that with going from 4 to infinity. So this would be your answer in interval notation. Now up here, let me kind of point this out. With the test intervals that we had listed here, notice I was just using parentheses because that's giving us the interval we're looking for. But for the solution, if the value can be equal to the endpoint, you need to make sure that you use a bracket to indicate that it is equal to that number. Okay, and of course, if we look at this now on your calculator, I know we quickly looked at the graph before, because we're looking for values that are greater than or equal to, that means we're looking for values that are above the x-axis. So if you look here, we have 1, 2, 3, 4. This point here would be a negative 4. And if we go to the left to negative infinity, that's given us a part of the graph that is above the x-axis. And then over here at positive 4 to infinity, you're getting this part of the graph, which is also above the x-axis. So that corresponds to our solution here for negative infinity to negative 4, and then from 4 to, whoops, not 8, this should be to infinity. And if we wanted to look at this solution on a number line, then you would simply look at negative 4, and we'll mark off here as positive 4. You would go strictly to the left of negative 4 and then to the right of positive 4. And once again, realize that here we're using brackets instead of parentheses. All right, if we move on to our next example, we have x plus 2 quantity squared less than or equal to 25. So once again, to start off, we want to find the key points, or again, that's really the zeros. And to do that, we want to take this equation and we could set it to 0, or we could do like we did before. For example, if we wanted to set this to 0, we would get x plus 2 squared minus 25 is less than or equal to 0. Now, in order to solve this, we would need to square the binomial and subtract 25. So I'm going to quickly do this. So we get x squared, and then plus, we have 2x and 2x, which becomes 4x, plus 2 squared is 4 minus the 25. So then if we simplify this, we have x squared plus 4x, and 4 minus 25 would be a negative 21. Okay, so this is one way you can go about finding the zeros. And once again, now that we have all of this equal or less than or equal to 0, we could simply then factor by x and x, and we would have 21 would be 7 and 3. And we have a plus 4, so that means we need a positive 7 and a negative 3, which we end up with x is equal to a negative 7 and x is equal to 3. So again, we have our key points. Now, just real quick here, an alternate way to do this. If we left this as x plus 2 squared less than or equal to 25, once again here, we could have taken the square root of both sides, and you would have ended up with x plus 2, and the square root of 25 would be plus or minus 5. So you would have ended up with x plus 2, and we could think of this as equal to 5, and x plus 2 is equal to a negative 5, and realize you're going to get the same thing that we had over here. We would get x equals 3 and x equals a negative 7. So because this was a nice perfect square, we could have easily taken the square root. So either technique you want to use is perfectly fine. So once we get the zeros, or these key points of negative 7 and 3, we once again want to identify your test intervals. So that means we're going to look at from, again, we're going to start at negative infinity. Whoops, I want to write negative 8 again. So it's negative infinity all the way up to negative 7, and then from negative 7 to 3, and then from 3 to infinity. And notice here, I want to kind of emphasize this again. I mentioned it earlier. Notice I'm listing these numbers from smallest to largest. In other words, negative infinity up to their next smallest number is the negative 7. So I want to go from negative infinity to negative 7, and then from negative 7 to 3, and then 3 to infinity. So if you notice the intervals, if you're thinking of going from left to right, we're going from smallest to largest. So make sure you're setting it up in that order. And now we pick a test value. So I'm going to pick here a value of negative 8. And between negative 7 and 3 is 0, and something bigger than 3 is 4. And if we look at then the polynomial value, then that means we're going to simply plug these numbers into the polynomial function. And once again, if you prefer, we can always go to the calculator. We'll clear out the previous function, and we would type in, let's see, I'll just type in the parentheses. We had x plus 2 squared, and that was minus 25. So if I go to the table, and I'm just going to simply hit delete to clear out the other values, and we want to type in negative 8, 0, and 4. So negative 8, 0, and 4. We get positive 11, negative 21, and a positive 11. So we have 11, negative 21, and 11. So once again, the conclusion is that we have a positive, a negative, and a positive. So how can we use that to identify the solution? Well, for the solution then, we're looking for values here that are less than or equal to 0. So that means we're looking for a negative value. So that means we would look at the interval here of negative 7 to 3. And because this was less than or equal to, that means we're going to include the endpoints. So we would use a bracket on the negative 7, and then also a bracket on the positive 3. And then if we look at the solution on a number line, we would locate negative 7, locate positive 3, and we would simply put a bracket on negative 7 and on 3, and we would highlight in between. All of the numbers in between, including the endpoints, would be a solution. So let me emphasize that. This is graphing all of the values of x. So all of these values in this interval, including the endpoints, would be solutions that we could substitute in for these x values, where this would be less than or equal to 0. And once again, to finish up, if we were to look at the graph, we can verify this. Well, remember, we had a solution of -7 to 3. Well, looking at the graph, here we have -7, over here we have +3. Where is this less than or equal to 0? Well, obviously the graph is going down, and we can see between -7 and +3, the graph over here is below the x-axis, and over here it's below the x-axis, so we know therefore it would be negative.